this video we will learn how to given a algebra tiles arrangement like a rectangle made of algebra tiles, we will learn how to represent that rectangle as a quadratic expression and then factor the quadratic expression. So we will learn two things. First, to express the given rectangle as a quadratic expression, and secondly, to factor the quadratic expression. So now let's take a look at this algebra tiles rectangle. Okay, so imagine that is what is given to you. So how do we actually first of all write it as a quadratic expression, and then secondly how do we factor it? Our method is actually to write the area of this rectangle using two different methods. The first method is to write the area of the rectangle using tiles. Okay, now see, we have in this case several tiles which make up the rectangle. How many x squared tiles are there? There is one x squared tile. Okay, so that has area x squared. So we have one x squared tile. How many x tiles are there? 1, 2, 3, 4, 5, 6, 7. So there are 7 x tiles, and each of them has an area of x. So 7 times x is 7x. So we have 7x, and then we have 1. Okay, and then how many 1 tiles are there? There are 10 1 tiles. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of these 1 tiles will have an area of 1. So 10 of those will give an area of 10. So then plus 10. So the total area will be 1 times x squared plus 7x plus 10, which means 1 x squared tile, 7 x tiles, and 10 1 tiles, which is x squared plus 7x plus 10. That is the quadratic expression which is represented by this tile arrangement. Now how do we factor it? The way to factor the quadratic expression is pretty easy. What we do is we kind of measure the length and the width of the rectangle, and we know that the area is what? Length times width, correct? So if you know the length and if you know the width, then we know the area, correct? Okay, so let's find the length. So what's the length? So let's measure. Okay, so what's the length of this? This is an x squared tile. So the length and the width of an x squared tile is x and x. So this is x. This is an x tile. So the shorter side of the x tile has length 1. So this piece is 1. So x plus 1 plus 1 plus 1 plus 1. So there are 5 x tiles which give you 5 1s. So x plus 5. Okay. Now up there again we have an x for the width and 1 plus 1. So x plus 1 plus 1, everything's plus 2. So we have the length as x plus 5, okay, and then we have the width as x plus 2. So length is x plus 5, width is x plus 2. The total area is what? Length times width, which is x plus 5 times x plus 2, which is exactly the factorization, because no matter how you find it, the area is the area. Okay, so the area that we found at the beginning was x squared plus 7x plus 10. That has to be equal to the area that we found by measuring the length and the width, which is x plus 5 times x plus 2. So the moral of this lesson is that when you have an algebra tiles arrangement, the factors of the quadratic which is represented is nothing but the length and the width. So you want to find the first factor, you just measure the length, and if you want to find the second factor, you just measure the length, the width. So the first factor is the length, the second factor is the width. So by measuring the length and the width, we can find the factor of the quadratic expression. So this quadratic expression factors as x plus 5 times x plus 2. Now in this one we were given the algebra tiles arrangement, okay, but usually the case that we have to really drill ourselves is, what if the algebra tiles arrangement is not given? What if we are simply given the quadratic expression? Then what we can do is create the algebra tiles arrangement, and then by measuring the length and the width, okay, we can actually find the factors. But if the quadratic is a very simple quadratic, you don't even need the algebra tiles arrangement. You can just recognize some patterns and do it manually. And so we will learn all these methods in the lessons to